Hi everyone. Today we will be helping David work out this problem. I noticed there were 3 errors that I caught within his solution, so we're going to try and help him out. Originally, I did not know how to solve this problem on the test or the problem like it, but after going back and looking at the notes and re-watching the videos and reworking the problem on the test, some other practice problems, I feel a little more confident that I'll be able to work this problem out correctly. So let's go ahead and work out this problem. So 2 boxes on a double-sided ramp are tied together with massless string over a massless frictionless pulley such that box B is accelerating down the ramp. Box A has a mass of 30 kilograms and is on an incline of theta A equals 55 degrees. It also has a force of Fa equals 100 newtons, acting vertically upwards on it. Box B has a mass of 50 kilograms and is on an incline of theta B equals 25 degrees. A force of magnitude of Fb equals 250 newtons pointing down the ramp acts on box B. Both boxes have a coefficient of static friction, nu s, equals 0.63, and coefficient of kinetic friction, nu k, equals 0.33 with a ramp. So I went ahead and labeled all of the forces on our diagram and all the angles, and we are going to use these to help work out these problems. So the first question asks, find the magnitude of the acceleration of the boxes. So first what we want to do is we want to find F net for mass 1. So mass 1 is Fn plus Fa cosine theta equals m1g cosine theta, and F net equals ma. So Fn, we're going to isolate this, Fn equals m1g cosine theta minus Fa cosine theta. I believe David just had minus Fa. I don't believe that's correct. And that's because Fa is slanted and not parallel to the normal force. Its vertical component is. So this is why we'll be using Fa cosine theta instead. Now we're going to try and solve for tension, because we're going to need that in order to solve the acceleration, the magnitude of acceleration. So we're going to do tension plus Fa sine theta minus m1g sine theta, and you can see I have them labeled on the diagram. So m1g sine theta and then Fa sine theta, and that's going to equal our tension force going in this direction, minus the friction force. Sorry, I don't think I included that. And we're going to set it equal to m1a, mass times the acceleration. So in order, we're gonna try and get t by itself. So t equals m1a plus friction force plus m1g sine theta minus Fa sine theta. And then t equals m1a plus, for the friction force, we have nu k times m1g cosine theta minus Fa cosine theta, and these are all, the thetas are all 55 degrees for the side A, plus, and then our m1g sine theta minus Fa sine theta. So that is how we find t. And now that we have this part of our equation, we can move forward for mass 2, box 2. We're going to do the same thing. We're going to find F net. So Fn2 equals m2g cosine theta. This 2 is just to indicate which angle we're using as well, which would be 25 degrees. So we're going to use m2g cosine theta to find F net. So we have FB plus M2G sine theta minus the friction force minus T, our tension, and we're going to set it equal to M2A, or F net. So now we have FB plus M2G sine theta minus the new K times mg cosine theta. Let's see our mg cosine theta, and then we're going to subtract all of this by the tension that we get here. We're going to set it equal to the mass of box 2 times the acceleration. And I'm going to flip this over so you can see. Continue to onto the next page. So we wanted to set acceleration apart because we're trying to find acceleration. So we set the equation equal to A, and by doing so we got acceleration equals FB plus M2G sine theta, FB plus M2G sine theta minus nu K times mg cosine theta, which I believe was our equation here, minus T. Let's go back. And we plugged in our equation for T, which was right here. So we took this equation and plugged it in right here. This all here is the tension. So we have our part from box B, and then our part from the tension that we solved using the mass of box A. And so I went ahead and I plugged in all these values. I got 5.89 meters per second square. Now this is another problem that I saw in David's solution. I believe he put meters per second, and that's the unit for velocity. Meters per second squared is the unit for acceleration. So that's another problem with his solution. And then in order to calculate the magnitude of tension in the string, we have tension equals MA, so the mass of it, box A, times the acceleration, plus nu K times MA, the mass of box A, times gravity, times cosine theta A, minus FA cosine theta A, plus MA gravity sine theta A. And when I went ahead and plugged all of the values in for this, I got tension equals 454.55 newtons. Now you notice this is the third mistake that David made. He plugged in FA instead of FA cosine theta, which is an honest mistake. Same problem he did here. He just took this, plugged it into here, and yeah, so it's okay. We all make mistakes. I'm glad that I was able to learn from mine. So thank you for your patience, and